Here's the punctuated text. Betelgeuse, the red monster star on the edge of our cosmic system, is sending disturbing signals through space. Stargazers utilizing the James Webb Space Telescope have found something profoundly disturbing about this Goliath object. Notable researcher Brian Cox has given an intense cautioning. The inquiry that continues to come up is, are we going to witness a cosmic explosion, blast so immense that it will change the night sky perpetually? How about we hop right into the tremendousness of the universe? Stars are conceived, live, and kick the bucket in astounding ways. As of late, one star has grabbed the eye and worry of both space experts and the overall population. This star is Betelgeuse, a red supergiant that hangs out in the heavenly body Orion. It is exceptionally large and extremely old. Its special ruddy tone and evolving brilliance have long intrigued eyewitnesses. Yet, late occasions have uplifted interest in this vast Goliath. As we more deeply study Betelgeuse, we are nearly at a possibly great occasion in its set of experiences. However, what may these progressions in Betelgeuse mean? Are we seeing the beginning of a vast show on an inconceivably terrific scope? Betelgeuse is a heavenly monster multiple times bigger than our Sun. It's enormous to such an extent that on the off chance that it were to supplant our Sun, its surface would stretch out past Mars' circle, including Mercury, Venus, Earth, and Mars. This monstrous size not just features Betelgeuse's physical glory, yet in addition demonstrates its stage in the heavenly life cycle as a red supergiant. Betelgeuse is approaching the finish of its life. It is expanding and cooling during this stage, which follows the transformation of hydrogen into helium in its center. What might be said about Betelgeuse's age? This star is assessed to be between 8 and 8.5 million years of age, which is generally youthful in human terms, however, antiquated with regards to heavenly life expectancies. Over a large number of years, it has changed emphatically from a hot blue star to the red Goliath we see today. Now, in its last stage as a red supergiant, Betelgeuse's biography is coming to a significant second. Stars like Betelgeuse change over their lifetimes due to the consistent tensions of atomic combination and gravity. Another perspective that makes Betelgeuse stand apart is its interesting ruddy variety. This red shade comes from its cooler surface contrasted with stars like our Sun. The outer layer of the Sun is around 5,500 Kelvin, while Betelgeuse's surface is around 3,500 Kelvin. This cooler temperature permits Betelgeuse to produce light at frequencies that show up red to us. However, this variety isn't simply about appearance. It uncovers the star's actual state and the cycles happening inside its tremendous vaporous volume. The way that Betelgeuse's tone has changed after some time adds to its secret. Verifiable records from Roman and Chinese periods show that Betelgeuse was yellow around 2,000 years back. By the 9th century, Arabic stargazers noted it was red. This variety shift over mankind's set of experiences isn't simply a minor logical reality, yet additionally proof of the star's development. Another captivating normal for Betelgeuse is its very variable splendor. As a semi-ordinary variable star, its splendor changes on an occasional premise. This dance of brilliance has intrigued researchers and skywatchers for quite a long time. Normally, Betelgeuse undergoes a multi-day cycle and a more extended 5-year cycle. Sir John Herschel documented these cycles as early as 1836, and native legends might contain references to them that go back even further. However, what genuinely makes Betelgeuse strange is its incidental deviation from this example. Dissimilar to numerous stars that faint and light up normally, Betelgeuse now and again acts whimsically, suggesting complex and less comprehended processes at work inside its immense structure. As of late, cosmologists and stargazers overall were stunned by Betelgeuse's emotional and startling diminishing. This occasion, presently known as the extraordinary diminishing, started in late 2019. Betelgeuse, one of the most brilliant stars in the night sky and a conspicuous component of Orion, began to lose its light at a disturbing rate. By February 2020, it was at its dimmest. Betelgeuse, normally apparent to the exposed eye even in light-contaminated regions, turned out to be much fainter and, surprisingly, easygoing onlookers saw the change. However, the time oddity confounds observing. Betelgeuse's activities, since light takes some time to travel to us. We see Betelgeuse not as it is presently but rather as it was in the past. The light we see today left the star right around 725 light-years back. This delay makes it hard to anticipate and notice quick changes in its behavior. The Betelgeuse darkening occasion was a reminder of how difficult it is to notice the sky continuously and how we are aware of the vast, unusual worlds of space and time. Andrea Dupree, deputy head of the Center for Astrophysics at Harvard and Smithsonian, and her team closely monitored the events of Betelgeuse's celestial show as part of a 3-year study to track changes in Betelgeuse's outer climate. They utilized Hubble to notice the immense star. These perceptions gave new insights into how a variable star like Betelgeuse works. Variable stars routinely expand and contract, causing changes in their brilliance. Analysts had the option to look into the layers over the star's surface, warmed to some extent by the star's swirling convection cells. Because of Hubble's aversion to ultraviolet light, further investigation of the Hubble spectra taken at different times in 2019 and 2020 helped determine the speed of material in Betelgeuse's upper environment. The spectra, mostly made out of magnesium and titanium lines, revealed the star's atmospheric circumstances. The review studies showed that material was moving from the star's surface into its air at around 200,000 miles per hour. This hot, dense material eventually reached millions of miles from Betelgeuse, initiating the dust cloud that diminished the star during the 3 months of the explosion. Dupree and her team estimated that about 2 times as much material as expected was shot out from Betelgeuse's southern hemisphere. While all stars lose mass over the long haul, Betelgeuse's mass misfortune was particularly striking due to its rate compared to the Sun's. Astronomers speculated whether this event could be a forerunner to a cosmic explosion blast. Given the size of the mass delivery and subsequent darkening, being something like 725 light-years from Earth, any such blast would be apparent from our planet, offering an intriguing opportunity to notice a cosmic explosion very close. However, the inquiry remains: what does this darkening mean for Betelgeuse's future? Is it a sign that a cosmic explosion is inevitable, or is it just a transient occasion in the star's complex life? Several theories have been proposed to make sense of this rapid change. One popular theory suggests it could be a stage in the cosmic explosion blast process, given that Betelgeuse is approaching the finish of its life. Another theory posits that residue, possibly ejected by the star itself, could be obstructing our view. Betelgeuse and other red supergiants are known to shed material, which could accumulate into a dust cloud sufficiently thick to obstruct the star's light. A third theory considers changes in the star's photosphere, the apparent outer layer, which could affect its apparent brilliance. Spectroscopic studies showed that Betelgeuse's effective temperature decreased by at least 170 Kelvin around the time of the darkening, supporting this idea and demonstrating significant changes on the star's surface. Ultimately, the Hubble Space Telescope, humanity's careful observer in space, unraveled this odd occasion. That's what Hubble's observations showed. Betelgeuse's darkening was possible due to a gigantic launch of hot material into space. This material formed a residue cloud that clouded a part of the star's surface, decreasing the light reaching us. It was guessed that the residue cloud was made of exceptionally hot plasma ejected from a large convection cell on the star's surface and traveled through its hot climate to cooler outer layers. As it cooled, it formed dust grains, making a cloud that blocked light from about a fourth of the star's surface. So, what does this mean for Betelgeuse's future? Is it a sign that a cosmic explosion is going to occur, or just an interesting part in the star's long, complex life? Hubble's ultraviolet light spectroscopic studies, which started in January 2019, played a crucial role in understanding the events that led to Betelgeuse's darkening. These studies provided clues of dense, hot matter moving through the star's atmosphere. Several ground-based telescopes also observed the star's darkening in December 2019, particularly in its southern hemisphere. Initially, this ejected material was brighter than the star itself, but as it moved outward and cooled, it formed a foreboding shadow. The general idea is that this outflowing matter and the resultant foreboding shadow caused the sudden darkening of the star. This massive ejection is significant, positioning Betelgeuse at the center of astronomical studies. The star expelled around 400 billion times the mass typically ejected during a normal coronal mass ejection. This ejected material, weighing several times more than the Moon, provides significant insights into stellar cycles and Betelgeuse's behavior. But what does such a massive blast of matter mean for how we perceive Betelgeuse and cosmic explosions overall? It has significant implications for theories about cosmic explosions. Red supergiants like Betelgeuse are believed to lose mass at a steady rate before they explode at the end of their lives. However, the scale of this ejection challenges that idea, suggesting a more violent and possibly erratic end-of-life scenario for the star. Could Betelgeuse be gearing up for its grand finale while we all are still here on Earth? This massive star's destiny will unfold as it reaches the end of its life. As astronomers continue to monitor Betelgeuse, the star's recent behavior has raised fascinating questions about its future. The darkening event seen in late 2019 and early 2020 was uncommon in recent history. While variable stars like Betelgeuse are known for their brightness fluctuations, the extent and rapidity of this darkening caught many off guard. The event prompted intense study and speculation within the astronomical community. One of the key questions that emerged from the darkening event is whether it could be a harbinger of a cosmic explosion blast. Cosmic explosions are among the most powerful and catastrophic events in the universe, marking the explosive deaths of massive stars. For a star like Betelgeuse, which is approaching the end of its life cycle as a red supergiant, a cosmic explosion is a possible outcome. However, predicting exactly when such an event could happen is challenging. Betelgeuse's distance from Earth adds another layer of complexity to studying its behavior. Found approximately 725 light-years away in the Orion constellation, observations of Betelgeuse provide a window into the past. Light from the star takes over 7 centuries to reach us, meaning that we see Betelgeuse not as it is today but as it appeared hundreds of years ago. This time delay complicates efforts to monitor and understand rapid changes in the star's brightness and other characteristics. The recent darkening of Betelgeuse was particularly notable since it reached a level of faintness unseen in modern times. Amateur stargazers and professionals alike observed the star's apparent change in brightness, sparking widespread interest and speculation. Some observers wondered whether Betelgeuse might be in the initial stages of a prolonged dimming phase, or alternatively, if the event was a transient irregularity. In addition to visible light observations, astronomers used various telescopes and instruments to study Betelgeuse across different frequencies. UV and infrared observations provided complementary insights into the star's atmosphere and overall environment. These observations are crucial for piecing together the complex dynamics at play inside a star as large and evolved as Betelgeuse. The darkening event also shed light on the mechanisms through which massive stars like Betelgeuse lose mass. Understanding these processes is essential for modeling stellar evolution and predicting the fate of other red supergiants in the universe. Betelgeuse's mass loss rate, estimated to be significantly higher than that of our Sun, highlights the unique nature of stars in the late stages of their lives. While Betelgeuse's recent darkening captured headlines and scientific attention, the star's variability isn't a new phenomenon. Historically, astronomers and skywatchers have documented Betelgeuse's changes in brightness and variability over centuries. Ancient records from various cultures provide valuable insights into how the star appeared and behaved in the distant past. These historical observations contribute to our understanding of Betelgeuse's long-term variability and evolution. Looking forward, astronomers will continue to monitor Betelgeuse for signs of further changes. The star's recent behavior has raised intriguing questions about its future. The darkening event seen in late 2019 and early 2020 was rare in recent history. While variable stars like Betelgeuse are known for their brightness fluctuations, the scale and rapidity of this darkening event caught many off guard. The event prompted intense study and speculation within the astronomical community. Telescopes and observatories around the world will remain focused on Betelgeuse, ready to capture and analyze any future developments. The study of Betelgeuse is not just about deciphering the life cycle of stars, but also about exploring fundamental astrophysical processes. As one of the largest and brightest stars visible from Earth, Betelgeuse offers a unique opportunity to study the physics of stellar atmospheres, mass loss mechanisms, and the dynamics of cosmic explosion precursors. Beyond its scientific significance, Betelgeuse holds a cultural and symbolic place in human history. Named after the mischievous character from folklore, the star's prominence in the night sky has inspired artists, writers, and storytellers throughout time. Its distinctive ruddy hue and variable brightness have made it a celestial object of fascination and wonder. In conclusion, Betelgeuse continues to dazzle astronomers and the public alike with its dramatic changes and potential for future cosmic explosion activity. The recent darkening event highlighted the star's dynamic nature and raised important questions about its evolutionary path. While much remains to be understood about Betelgeuse's future, ongoing observations and advances in astronomical technology promise to unlock new insights into this cosmic giant and its role in the universe.